Hey everybody. So I really like these next couple of slides because I think they are extremely important and not discussed as often as they should be. And that is number one, that your nervous system, what we're focusing on right now, is going to work with other systems of the body. Please always keep that in mind. Your body is always going to be trying to continue homeostasis, and to do so, it needs to interact with all of the other systems of your body. Everything's connected, right? So, with that said, we also need to understand that there are different systems of the body that can produce similar types of tasks and will integrate with the nervous system. And that said, we have two systems that work very closely together, but are two different systems. And with that said, too, there are some differences. And the nervous system and the endocrine system, although they have a lot of similarities, they are two different systems. So let's talk about how they are different, right? So we do know they work together, but there are some significant differences, such as the fact that the nervous system is going to work very quickly. It's much faster than the endocrine system. So with that said, it's going to move at about 1 to 10 milliseconds to get its message across, and it's going to use electrical impulses as well as neurotransmitters to do its bidding. So it's very important to keep that in mind, as we just talked about in the last video, right? In this case, maybe a neurotransmitter hits the dendrites and tells the dendrite, hey, we need to send an additional signal somewhere else. That will then tell the cell to send an electrical signal down the axon, where it will release additional neurotransmitters, which are a chemical signal. So in this case, it went chemical signal to electrical signal to chemical signal. So that's just one example of the fact that you can use electrical and neurotransmitters in order to get something going. Chemical signals, electrical and chemical. It's also going to be very localized. So, for example, if my nervous system tells my arm to lift up so I can wave to the camera, it's going to tell my right arm in this case to lift up and then wave. You don't see my whole entire body jumping around because I want to lift up my arm, right? It's very localized. The signal's being sent down my right arm, and I can move that independent of the rest of my body. Also important. Not only that, but just if you do something for a long period of time, or something's interacting with your body for a long period of time, you can adapt to that. And the example here is wearing a watch. It could be wearing it really any clothes, right? You put your shirt on. Obviously, you feel that you put it on in the morning, but as you move throughout the day, hopefully, you will not be just constantly saying, wow, the shirt's so annoying. It feels so X, Y, and Z, right? Typically, you get used to it, right? If you put your watch on, you forget it's even there. Hopefully, you don't notice it all day. And that's a part of the one really nice part of the nervous system. If we look at the endocrine system, you're going to see some pretty significant differences. And the big one is that you're going to be using hormones in the bloodstream. And what's going to happen here are two things. Number one, it's going to be kind of slower relative to the nervous system. Yes, they're both very quick. For us, we don't really notice it, that there's much of a difference, but they are a little bit slower because those hormones need to get into the bloodstream first and then travel throughout the body to where the multiple places that it's going to end up. And that leads us to the second part, which is the fact that the endocrine system's hormones that are being released are systemic in many cases, meaning that they're going to reach many parts of the body and interact with many organs and organ systems throughout the body at one time. For example, let's say I see something that spooks me a little bit, right? So I'm walking down the street, all of a sudden a bear pops out of the woods, right? It looks angry. One, I don't know where I am, right? Why is this happening? But two, right? So if that happens, now there's going to be different hormones flying throughout my body, right? So adrenaline, I'm going to be amped up, right? Fight or flight, which we're going to talk about in a minute. So now my heart is going to start beating faster. My blood vessels are going to start to dilate, right? Many different parts of my body are going to start to interact at one time because of that. And so now I'm going to be pumped up and ready to either fight or flight. In my case, I'm probably running out of there because I don't want to get taken down by a bear. So with that said, the hormones are going to interact with many different systems of the body. Not only that, but after I'm scared, I just realized it wasn't even a bear, right? It was actually just, a plastic bag, right? Really, my vision's shot if that's the case. But now that I noticed that, I'm still feeling the effects of it. My heart's still pumping, right? I'm still really on edge. I'm starting to sweat still, right? Even though I know it's not a bear anymore, my whole body's still going because these hormones are going to linger on in my system for a little while after that stimulation has stopped. So these are a few big differences between the nervous and endocrine systems. However, they are going to work together in order to accomplish homeostasis. Here are just some of the other systems that the nervous system is going to interact with. Everything, right? So integumentary system, lymphatic, skeletal, digestive, everything is connected with the nervous system. And those neurons are going to carry those impulses throughout the body so that they can communicate with everything at all times in any scenario. If you have any questions with this, please let me know.